We just left a chapter known as Mendelian Genetics, and Mendelian Genetics was all about what happens typically. The idea that Mendelian genetics comes from a trait that is caused by one gene, and that one gene has a dominant variation or allele or a recessive. And every single time that a dominant allele, such as dominant A, was paired with a recessive allele, then the phenotype would always demonstrate the dominant trait. So many Mendelian traits only have two variations, but that's not always the case with genetics, as you might well be aware that humans don't always abide by that rule. So unfortunately, we're going to get into some exceptions to Mendel, and we're going to learn about each individual case. We kind of hit the big ones at the introductory level, but realize there are probably many, many, many more. So the first video I wanted to make was something called, most commonly referred to as incomplete dominance. I have seen it referred to as non-dominance as well. I more or less refer to it as incomplete dominance. Now this is a case where again you have a trait that's just caused by one gene, but technically neither of them are recessive. They both want to show through, they both have equal power, and there's reasons for it. We're not getting into the reasons why, but you kind of have both dominant alleles. So that comes into play when we have to notate, well, how do you do these different alleles? Because we can't say that one is dominant or recessive, and this notation indicates that you have a dominant allele and a recessive allele, so that's why it made sense. But since neither of them are recessive, we have to come up with another notation. In this chapter, notation is probably going to be one of the most important things that we look at. So it has one gene, but neither allele is recessive to the other. There still are only two alleles. We'll get into some cases where there's more possibilities than just two alleles. So we notate that. I kind of use the most common example first, and the most common example is going to be a gene that they find in a specific type of flower, and it does the coloration for the actual flower itself. So what we have a red allele, and so we notate it because it is technically, we'll classify it as dominant, as a capital R. But there is a white phenotype as well. We can't just automatically assume that this is going to be, it's not recessive, so we're not going to put a little r here. Instead, 9 times out of 10, and again there are different variations, unfortunately, I kind of choose the ones that I see most common. Here you have the notation of incomplete dominance. What you do is you capitalize the two different alleles, but you choose two different letters. That's how, to someone who understands genetics, they will understand what you're doing here. So this then plays out when we look up the different combinations that you can get with these two alleles. So what you can do is you can pair the two R alleles together, and you would not really be too shocked to see that you would get a red flower. If you pair up the two W alleles, again, not shocking, you're going to get the white phenotype. But what happens when you pair the red allele with the white allele? Since both of these alleles are technically of equal power, if we can kind of say that, they both want to show through. So what starts to happen is you get a blending of the two extremes, as I call them. So what you're going to get is a pink phenotype. When you mix red with white, you get the pink. So this is the most common example. Many times they give you the genotypes to start with, but what I suggest that you do, this is probably your go-to example. If you have one example that you are going to compare every unknown situation to, try and find a go-to, and it would be the red, the pink, and the white. What you often do is you're given a situation where maybe they don't tell you which one is the middle. This is the hybrid between the two extremes. So I think that's how you kind of approach it. You look at the ones that are the extremes, in this case white and red. Those are the ones that actually get the allele combination. There is no allele for pink. There is no capital P. There are still only two alleles, the R and the W. But the hybrid, or the heterozygous state, is the one that is going to get you to that pink phenotype. So we'll kind of start very simple. If you're doing a monohybrid cross where you're doing a red flower mixed with a pink flower, it's actually pretty easy to build the genotypes because there's not multiple combinations of genotypes to have a different phenotype. There's only one for each. So when I tell you anything on the right, it automatically gives you the information about the genotype. I don't have to use homozygous or heterozygous, so that's kind of a bonus to building it. It's less confusing for that part. So what you do is the same idea. We're going to separate to make our gametes. We'll put one parent there, we'll put the pink parent up here. You'll create your Punnett square. Obviously we're doing a monohybrid to start, keep it simple. You're going to fill in, and what you'll get is your example. We have 2 red to 2 pink. All right, so that's an example of a incomplete dominant situation. Other examples you might see deal with length. If you ever see something, these are the clues. A lot of times with incomplete dominant situations, you see 3 variations of phenotypes. 3. 1, 2, 3. Sometimes they are relative terms like small, medium, large, short, average, long. Do you see how these are relative? But there's only 3 variations to them. What you have to be trained to do is spot the end or extreme phenotypes and recognize these are the ones that get in most cases, the letter for the actual allele. So you would use potentially an S for small, an L for large. So small would have to be the homozygous state, large would have to be the homozygous state, medium would be the hybrid. Short, same thing, S's, L's, those are the extreme, with the average being the one. This is the blended one. Recognize that's the heterozygous. So you just have to start doing more examples and you'll start to recognize the extremes. They could be very nice. So for example, I want to show you one that's in your packet. Here they have an example where they give you the allele, so that makes it already easy for you. So I'll zoom that in. Here you have, they choose the letter B to represent a black chicken, WW represents a white chicken. Most common when I see this, actually, when the B and W combine, it often codes for like a grayish color, but apparently in this chicken it codes for a blue color. So what we'll do, we're going to cross a blue with a blue, the hen versus the rooster. So as I have trained you to kind of do, the alleles have already been notated. I don't need to do a key. The parent cross, the blue hen, which is the hybrid combination, is going to mix with the blue rooster, same idea. So we're going to cross to create the Punnett square. It's going to give us a lot of variation. And then our phenotypic ratio looks like we'll have 1 black to 2 blue to 1 white. So there's just another example. We'll do more if you need it, but the biggest key here is trying to recognize the detail that you have 3 phenotypes all the time when it comes to incomplete dominance. All right? Thank you.